E is the midpoint of the side AD of the trapezium ABCD with AB being parallel to DC. Just first thing is we'll just write a rough diagram. So we know that it's a trapezium. So what is the property? So go back to your sheets. Always have a look. So we have sides to be, one pair of opposite sides are equal, two pair of adjacent angles add up to 180 degree. Nothing to tell with diagonals, and area of trapezium is given by that particular formula. So there is nothing much that we need to bother other than keeping two lines parallel to each other. And we should try to draw a trapezium which is parallel to this, right? Parallel to each other, that is, and nothing else. Everything else has to be random. So E is the midpoint of AD. So this would be your midpoint, and we have this to be E, with AB being parallel to DC. Okay. A line through E drawn parallel to AB intersects BC at F. So something like this. So this point is F. Show that F is the midpoint of BC. So if this is X, this is also X. Something like that. So for this, we have to make use of, again, yes, midpoint theorem. So for that, we'll do a bit of construction wherein you have AC and EF AC and EF meeting at O. So we did a bit of construction, that is, we join AC and let O be the point of intersection. Then intersection of what? We have to mention that also. Intersection of AC and EF. And what else can we tell? So we have been given the following, that we have AB parallel to DC and we have AB parallel to EF. Because these two are parallel to each other, what can we tell? This infers DC is parallel to EF, right? Reason being, lines parallel to a common line are parallel to each other, Okay, so we basically prove that all these three lines are parallel to each other. With this in mind, with this in our understanding, now we can write the proof. It's quite simple actually. First we'll go with triangle ADC. So we have, my bad, wrong layer. In triangle ADC, what do we have? We have EO parallel to DC. Okay, we just proved that at the top, right? Then E is the midpoint. So we have two following conditions, that is EO is parallel to DC and E is the midpoint. From this, what can you tell? Midpoint of one of the sides, that is AD. So with this, what can you tell? Yes, this infers that O is the midpoint of what? AC. That's correct. How is that we are able to tell this? Yes, because of midpoint theorem. Okay, next is which one? Yes, in triangle ABC, right? We have as O is the midpoint and we have OF being parallel to AB. So this, from this we can infer F is the midpoint of what? Of BC. That's it. That's our proof. Quite simple, is it not? A small correction. We have converse of midpoint theorem, not midpoint theorem. I mentioned it as a midpoint theorem. It is converse of midpoint theorem.